Hello. Today we are going to discuss about the 8085 introduction. The feature of Intel 8085 are: it is an 8-bit microprocessor, it is a single chip NMOS device with 40 pins, it has multiplex address and data bus, that is AD0 to AD7, it works on 5 volt DC power supply, the maximum clock frequency is 3 megahertz while minimum frequency is 500 kilohertz. It provides 74 instructions with 5 different addressing modes. It provides 16 address lines, and with the help of 16 address lines the total memory address capacity is 64K, that is 2 to the power 16. It generates 8-bit input output addresses. So, it can access 2 to the power 8 equal to 256 input ports, that is 256 IO devices. It provides for 5 hardware interrupts, that is trap, RFT 5.5, RFT 6.5, RFT 7.5 and INTR. It gives us accumulator, 1 flag register, 6 general purpose registers and 2 special purpose registers. These special purpose registers are stack pointer and program counter. It provides serial lines SID, that is serial input data line, and serial output data line. So, serial peripherals can be interfaced with 8085 directly. This is the pin out diagram of 8085. There are the pins, 40 pins including the address and data bus. We discussed the some of the important pins AD0 to AD7. This is a multiplex address and data line bus. It carries the lower order 8-bit address as well as the data bits, but at different times. A8 to A15, this is a tri-stated higher order address line, which is a unidirectional bus, because it carry the address and address is always generated by the CPU. So, this is a unidirectional bus. Another signal is ALE, that is address latch enable. It is an output signal. It goes high when operation is started by the processor. S0, S1, these are the status signals used to indicate type of operation. Read signal, this is active low input signal used to read the data from IO devices or from memory. WR signal, this is an active low signal used to write the data on the memory or on output devices. Another pin is the ready pin. This is an output signal used to check the status of the output device. If it is low, microprocessor will wait until it is high. Trap, it is an edge triggered highest priority non maskable interrupt. After the trap, restart occurs and execution starts from the address 0024H. RFT 5.5, 6.5 and RFT 7.5. These are the maskable interrupts and have low priority than the trap. INTR and INTA. INTR is an interrupt request signal, after which microprocessor generates interrupt acknowledge or interrupt acknowledge signal. IOM is an output pin or a signal used to indicate whether 8085 is working in the IO mode or memory mode. When this signal is high, it means the CPU is going to perform the input output operation with the IO devices, and if this signal is low, then this will identify that the CPU is going to perform the operation with memory. Other control signals are hold and hold acknowledge. Hold is the input signal and they are used in the DMA mode. When microprocessor receive hold signal, it completes the current machine cycle and stops executing next instruction. In response to hold, microprocessor generates hold acknowledge, that is hold acknowledge signal. Reset in is an input signal. When reset in is low, microprocessor restarts and starts execution from the location 0000H. Serial input data, this is the input data pin used to accept serial 1 bit data. X1, X2, they are the clock input signals and are connected to the external LC or RC circuit. These are divided by 2. So, if the 6 megahertz is connected to X1, X2, the operating frequency will become 3 megahertz. So, all the operations of the microprocessor with the memory and I/O devices, they will be operated with the help of clock frequency of 3 megahertz, that it will decide the speed of the operations. VCC and VSS, they are for the power supply. This is the block diagram of 8085, internal block diagram. It consists of an 8-bit accumulator, one 8-bit temporary register, a flag register. This flag register is of 8-bit, but out of 8 only 5 bits are used for the flags, the remaining 3 remains unused. These different flags will be discussed later on. And then instruction register, the instruction which is fetched from the memory first is transferred to the IR, which is an 8-bit register. Here the instruction will be decoded, and accordingly the different the output of the decoder will go to the timing and control unit, which will generate the appropriate timing and control signal for the execution of the instructions. The arithmetic logic unit, it can perform the operations over the 8-bit data. The arithmetic logic unit of 8085 is capable of performing the various arithmetic and logical operations. It can perform the addition, subtraction, and in the logical operation it can perform the logical AND operation, logical OR operation, exclusive OR operation, complement, shifting of the numbers. So, all these operations they can be performed in the arithmetic logic unit. In addition, 8085 consists of the registers, general purpose registers, which are B, C, D, E, H and L. They all are 8-bit registers. These registers, they are used for the intermediate storage of the data. They can be used as a single register, or they can also be used as the pair. The valid register pair in the 8085 will be BC pair, DE pair and HL pair. So, when we need to deal with the 16-bit numbers, we can make use of register pairs. In addition, the general purpose registers, stack pointer points to the top of the stack, program counter, incremental decremental register, address buffer and data address buffer. This serial input output control part of the 8085, which provide 2 input lines, SID and SOD line. These are the various functions of the accumulator temporary registers. Temporary register is not available for the user. All the arithmetic logical operations are done in the temporary register, but user cannot access it. Flags, there are 5 flags. The flag register along with the accumulator is called the program status word. The various flags, they are the first of all the lowest least significant bit of the flag register is the carry bit, then the next bit remains unused, then next is the parity bit, auxiliary carry bit, 0 flag and sign flag. Sign flag is set when result of operation is negative, that is when the leftmost bit of the result is 1, then this sign flag will become set. 0 flag is set when the result of an operation is 0. Auxiliary carry flag is set when there is a carry out of the lower nibble or the lower 4 bits of the operation. When 2 8-bit numbers are being added and the addition of the first 4 bits of one number with the first 4 bit of the second number generate a carry transferred to the 5th bit, then auxiliary carry flag is set. Then final the carry flag when there is a carry generated by an operation. Carry means when the result of an operation exceeds the 8-bit, then we say a carry has been generated, and in that case the carry flag will become set. Parity flag is set when result contain even number of ones. The remaining 3 positions they are the do not care flip flop or they are not used. Register groups, in the register groups they are the temporary register W and Z which are not available for the user. They are loaded only when there is an operation being performed. General purpose registers, in 8085 there are B, C, D, E, H and L for the various they are used for the various data manipulations, and we have stack pointer and program counter. Stack pointer is a temporary storage memory 16-bit register. Since there are only 6 general purpose registers, there is a need to reuse them. Whenever stack is to be used, previous values are pushed on the stack and after the program is over, these values are popped back. Program counter, it is a 16-bit register used to point the location from where the next instruction is to be fetched. When a single byte instruction is executed, PC is automatically incremented by 1. Upon reset, PC contents are set to 0000H and the next instruction is fetched onwards. Instruction register, when an instruction is fetched, it is executed in the instruction register. This register takes the opcode value only. Instruction decoder, decode the instruction from the instruction register and then to control block. Timing and control, this is the control section of microprocessor, it accepts the clock inputs. Interrupt control, the interrupt control section of 8085 accept the different interrupts like trap, RFT 5.5, 6.5 and 7.5 and INTR. Serial IO control, it is used to accept the serial 1-bit data by using SID line and SOD signal, and it can be performed by using SIM and REM instruction. Now, instruction set of 8085 is divided into 5 groups. First one is the data transfer group. The example is move from the source register to the destination register, move RD, RS. This is an example shown. Next is move data from the memory to the register. Before execution of this, the address of the memory must be in the HL pair. In this case, the HL register pair act as a memory pointer. No flags are affected, addressing mode will be indirect. Then MVIR data, data is immediately transferred to the register R. This is an example given. In this case also no flags affected, and this is the addressing mode will be immediate addressing mode. Another is LXI RP, RP stands for register pair. Valid register pair in this case will be either B pair, D pair or H pair. B pair means BC register, D means DE register pair and H for HL register pair. In this case we can also use the SP stack pointer, no flags are affected, and this is also the immediate addressing mode. Then FT address, this instruction store the accumulator data to the given address. LHLD address, it load the HL pair with the data from the addresses. Exchange the data from the HL pair to D pair. When we need to we are dealing with the 16-bit numbers, so we can make use of this exchange instruction which transfer the 2 16-bit number which are in the HL pair and DE pair. In this case also no flags are affected, and this comes under the register addressing mode. Then this in move the data from the address to accumulator, move data from accumulator to the given address. Here this 8-bit address is the address of the port. This is some example program. Arithmetic group, the first one is the add-R, add register content with accumulator and the result in accumulator. This is add C, means it will add the content of C with A and the result will be in the register A. Add M, add H or L register content with accumulator and result in A. ADI data, add immediately data with accumulator and result in accumulator. ADI 30H, and this the 30H, will be added to the accumulator immediately and the result will be stored in the accumulator. ADCR, add register content with accumulator and carry, and result will be in the accumulator. This is an example program. Write a program to perform 16-bit addition of 1, 2, 3, 4 H and 4, 3 to 1 H. Store answer at H and L register. The lower order number of 4, 3 to 1 is transferred to B, then in the A 3, 4, 4, 3 in the C, 1 to H is transferred to the D, then we perform the B, add B means B will be added to accumulator, and then we move accumulator to L, move C to A, ADC C, D, move A to H and then RST 1. In the arithmetic group, next instruction is the subtract R. This instruction subtract register content from accumulator and the result finally is in the accumulator. Subtract with borrow R. This subtract register content from accumulator with borrow and the result finally will be in the accumulator A. SUI, subtract immediate data from accumulator and the result in the A. DAD RP, add specified register pair with HL register pair. This DAD RP is used for the addition of two 16-bit numbers. One of the two 16-bit number is always in the HL pair, the second 16-bit number can be in any other valid register pair and the result will be finally in the HL register pair. Only carry flag will be modified. This register addressing mode DAA, this is the decimal adjust accumulator. This instruction is used to store result in BCD form. If lower nibble is greater than 9, 6 is added, while if upper nibble is greater than 9, 6 is added to it to get the BCD result. All the flags are modified in this case. This comes under the register addressing mode. Another is INRR. This is increment the register, the 8-bit number of the register by 1, decrement the 8-bit number in the register by 1, increment register pair. Whenever we see X in the instruction, it means we are talking of the register pair. In this case, the 16-bit number of the given register pair is incremented by 1, ANER. Now, these comes under the logical group. ANER perform the logical AND operation between two 8-bit number, one of them is in the accumulator, second can be in any of the register. The different values of R can be either B, C, D, E, H, L or even accumulator itself. ANI data, here the it perform the logical AND of the two 8-bit number. One of the number is in the accumulator, second number is given in the instruction itself in the form of this data bits. Then ORA R, it perform the logical OR operation of two 8-bit numbers. One of them is in the accumulator, second can be in the register R. All the flags are registered affected by the instructions of logical group, and this comes under the immediate addressing mode. Then exclusive OR XRAR, this will perform the logically exclusive OR operation between two 8-bit number, one of them in the accumulator A and second can be in any of the given register pair. One of them is in the accumulator, second can be in any register. Then compare R, this instruction compare the two 8-bit number, one of them is in the accumulator, second is in the register R, the two numbers are compared. In this case, the content of register R is subtracted from that of accumulator and according to the flags that the comparison is made. Means if after the compare R carry is set, it means the 8 bit number in the register R is larger, is greater than that of accumulator A. If both the numbers are equal, then 0 flag will be set, and if neither 0 nor carry flag is set, it means the number in the accumulator is greater than the number in the register R. So, and after the compare R, the numbers in the register R and A, they remains unchanged. All the flags are affected. Then CPI data, here also the comparison is made between two 8 bit numbers. One of them is in the accumulator, second number is in the is given in the instruction itself. RLC, this is rotate the accumulator, the 8 bit number of the accumulator to the left without carry. All the when we execute RLC, all the 8 bits of the accumulator, they are shifted 1 bit position to the left side, means the 8th bit of the accumulator will become the position of the 0th bit of the accumulator, and the 7th bit of the accumulator will take the position of 8th bit of the accumulator. So, all the 8 bits they will be shifted to the left 1 bit at a time. RAL, rotate accumulator with carry, means in this case the 9 bits are rotated, 8 bit of the accumulator and 1 bit carry. When we execute RAL, all the 9 bits they are rotated to the left 1 bit at a time, that is the carry bit will become to the first bit of the accumulator, and the 8th bit of the accumulator will be transferred to the carry bit. In this way, the complete 9 bits they will be shifted, they will be rotated to the left. RRC, rotate accumulator right. In this case, the accumulator, the 8 bit number in the accumulator will be shifted to the right 1 bit. This is an example program. Write a program to reset last 4 bit of the number 3 to H store result. We can reset the any bits of the given number by performing the logical AND operation. Example is given here, you can see, because we have to reset the last 4 bit. So, therefore, we are using the last 4 bit as 0, and we are performing the AND operation with the F0. Then in the branch group, the first one is the JMP address. This is an unconditional jump to the specified address. After this instruction, the program counter is loaded with this location and starts executing, and the content of the program counter are loaded on stack. Then this is call, whenever we need to call the subroutines in the program, we can use this. This is an unconditional call from the given address. In this case, no flags are affected. Conditional jump, this is jump if carry, jump if not carry, jump if 0, jump if not 0, means these jump will take place only if the specified conditions are true. That is, when we talk about first the jump carry JC, it means if the carry flag is set, only then the jump operation will take place, otherwise the program execution will continue in the sequential way. In the same way, these all the remaining one, jump if not carry, jump if 0, jump if not 0, jump if parity even, jump if parity odd, jump if plus, jump if minus. Call if carry, call if not carry, call if 0, call if not 0, call parity even, call parity odd, call the subroutine only if plus, call if minus. And the last instruction of every subroutine must be the return. that is RET. This is the return from the subroutine. When we write the instruction, we are calling a subroutine, the control of the execution will be transferred to the specified location of the subroutine, and the last instruction of the subroutine must be the return, that is RET, and when RET executes, the control again transfer to the main program at the same point where the subroutine was called. RST, restart instruction, they are sometimes also called the software interrupts. After this instruction, the program counter goes to the address 008 and start executing from that address. No flags are affected. And there are the various instructions in 8085 RFT 0 to RFT 7. So, when any of them is executed, the control of the execution of the 8085 is transferred to the specified address, that is for RFT 0 it will go to initial location of the memory, that is 0000H. For RFT 1 it will be 0008H and so on. These addresses they are find out by multiplying these digits, that is 0, 1, 2, 3, 4, 7. The number RFT, the number given in the RFT is multiplied by 8 and converted into hexadecimal form will give us the address of the corresponding memory location. Then in the stack and machine control, the post RP, suppose HL pair data is this, SP is initialized to FF. So, these instructions they are used for the stack memory. Pop RP, pop register pair content from the stack. The top two elements of the stack they will be transferred to the, they will be read from the stack. Exchange top with HL, exchange HL register pair content with top of stack, that is exchange top with HL. The top two element of the stack memory they will be exchanged with the HL pair contents. Addressing modes of 8085. As we already discussed, there are 5 addressing modes in 8085. One of them is the immediate addressing. Immediate data is transferred to the address or register. The example are MVI A20H. It transfer immediate data 20H to accumulator. Number of bytes, it can be either 2 byte or 3 byte long. First byte is always the opcode byte, second byte will be 8 bit data, and third byte will be the most significant 8 bits of the 16 bit data. Next addressing mode is the register addressing. When the operands of the instructions they are specified to the be in the registers, then the addressing mode is called the register addressing. Example is given. Here the operation is being performed over the content of the registers. When the operands they are within the CPU register itself. No number is required to be read from the memory or from IO devices. The numbers they are already in the CPU registers. Then it is the register addressing mode. Direct addressing, data is transferred from the direct address to the other register or vice versa. When the operands are in the memory and address of the memory is given in the instruction itself, then that is the direct addressing mode. Example is given LDA C200H. Here C200H is the address of the memory where the number is there. It transfer the content from the C200H to accumulator. Number of bytes, there are 3 bytes long. First byte is the opcode, second byte is the lower address, and third byte is the higher address. Indirect addressing, data is transferred from address pointed by data in a register to other register or vice versa. Example is move M to A. Here The 8-bit number is in the operands are in the memory, address of the memory is in the register HL register pair, and those HL register pair they are referred in the instruction by letter M. It means this is the indirect addressing mode. These instructions are also of 3 bytes. First byte is always the opcode, second and third byte is the can be the address.